Introduction: The impossible precision. In space, there are no accidental stops. Objects either orbit, crash, or fly off into the infinite void. But what the interstellar traveler 3I/Atlas is doing right now is forcing astronomers to nervously double-check their calculations. It appears that this object is intentionally slowing down. And it isn't doing this just anywhere. It is performing this maneuver exactly at the boundary of Jupiter's Hill sphere, the invisible line where the gas giant's gravity begins to overpower the pull of the sun. It has approached this boundary with a precision that is frankly terrifying. The margin of error is just 1 part in 26,000. To put that in perspective, that is like throwing a needle from Los Angeles and having it land perfectly on the edge of a coin in New York. No known natural comet has ever behaved like this. This maneuver has triggered a tidal wave of questions that official science cannot yet answer. If this is not a natural trajectory, then what or who is guiding its motion? Part 1. The Strange Guest. The story of 3I/Atlas began as a routine astronomical event. At first, it appeared to be just a distant speck arriving from deep interstellar space. Its speed and its hyperbolic orbit all suggested it was just another rock that would pass through our system and vanish forever, much like Oumuamua or Comet Borisov. But as the object approached the Sun, the anomalies began. After passing perihelion, its closest point to the Sun, it experienced an acceleration. Now, this can be normal for comets. Ice melts, gas vents out, creating a rocket effect. But usually, comets tumble and wobble, making their thrust chaotic and unpredictable. Atlas behaved differently. The acceleration was weak but eerily stable. It gave the object a gentle, persistent push, shifting it from its original course onto the exact trajectory that is now leading it to park near Jupiter. Over 200 observatories around the world have recorded this deviation, and with every new measurement, it became clearer. This was not an error. This was a course correction. In the comments sections under news reports about this event, the mood is a mix of fear and aggressive skepticism. One viewer writes, "No, it didn't stop at Jupiter because it's not supposed to be there until March 16, 2026. Stop lying to the public." And that is a fair point. Formally, the closest approach is still in the future. But the modeling shows that the object has already adjusted its speed and angle to enter this specific zone perfectly. It is like watching a train begin to brake miles before it reaches the station. You don't need to wait for the stop to know what the intention is. Part 2. The Mathematics of a Miracle. Let's talk about the numbers because they are what make this story so insane. Atlas is expected to pass Jupiter at a distance of about 33 million miles. But it isn't aiming for empty space. It is aiming for a point of equilibrium. The outer boundary of the Hill sphere is a very narrow, sensitive zone. To hit it by accident is statistically equivalent to winning the lottery 10 times in a row. Most natural objects either fall into Jupiter's massive gravity well or sail right past it. To hover on the edge is unnatural. One user in the comments offers a bold sci-fi theory. This is definitely not a comet. It is a mothership. It will cut its engines to hover, then release probes into Jupiter's atmosphere. Landing, research, capture. Does that sound like fiction? Perhaps, but when you see an object behaving as if it has a flight plan, it is difficult not to start thinking about a pilot. Part 3. 4 Theories. Scientists are currently looking at 4 explanations for what is happening, and frankly, none of them are perfect. Theory 1. Data error. This is the most boring version. Could we simply be measuring the speed wrong? It's the conservative answer. But with 230 observatories providing the same data set, the probability of a collective hallucination by every telescope on Earth is approaching 0. Theory 2. The lucky outgassing. Maybe there is a unique geyser on the surface of the comet that fires strictly in one direction, acting like a stabilized thruster. It is physically possible, But for this to work, the geyser would have to fire continuously for months without changing intensity or direction. It's like watching a balloon deflate and fly in a perfectly straight line instead of spiraling wildly. Theory 3. Coincidence. The universe is vast. Maybe we are just lucky enough to see a 1 in a billion event. But skeptics in the comments, like one user who noted, "This is only the third interstellar object we've seen, and it didn't fragment. I have to believe this is 100% BS," make a strong point. Statistics work against the coincidence theory. If every interstellar guest behaves strangely, remember Oumuamua. Maybe the problem lies in our understanding of what is normal. Theory 4. Artificial origin. The most provocative version. What if Atlas is using Jupiter's gravity as a brake or a slingshot? Space agencies do this all the time. We use giant planets to speed up or slow down our own probes. Think Voyager or Cassini. If Atlas is a probe, the edge of the Hill sphere is the perfect place to shed velocity, take a look around, or recharge batteries using Jupiter's massive magnetic field. As one commenter shrewdly observed, it seems to be taking inventory of how the solar system has changed since its last visit. Even astrophysicist Avi Loeb has asked the question, perhaps we are not the observers here, but the observed. Part 4. Why Jupiter? Jupiter is the king of the solar system. Its gravity is the primary engine and the primary hazard for everything that flies past. NASA engineers spend decades calculating trajectories to utilize this power. For a natural rock to enter this zone tangentially and effectively park on the edge is like a surfer catching a tsunami and freezing perfectly on its crest. Another viewer suggests an interesting physics-based idea. Maybe it stops because it feels another density and pressure, like deep-sea diving. Maybe Atlas has an element that repels the sun's force. While this sounds scientifically unconventional, the core idea of interacting with fields makes sense. If the object is a light sail, as was theorized for Oumuamua, the balance between light pressure and gravity could create exactly these kinds of hovering effects. Part 5. 3 scenarios for the future. We are approaching March 16, 2026. What happens at this point? Scientists have 3 scenarios. Scenario A. Fragmentation. The gravitational forces at the edge of the Hill sphere are monstrous. Tidal stresses could rip a loose, icy comet apart. If Atlas crumbles, we will see its insides. This would give us a unique chance to study matter from another star system, but it would also kill the mystery. Scenario B. Payload release. This is the most intriguing option. Some researchers admit that the deceleration could be intended to separate fragments. If Atlas releases a swarm of smaller objects that enter Jupiter's orbit or head toward other planets, maybe Earth, that would be undeniable proof of artificiality. As one comment darkly predicts, if it does a course correction and heads for the Earth, kiss our collective asses goodbye. Scenario C. A new maneuver. If Atlas reaches the boundary and changes course again, turns, accelerates, or enters a polar orbit, it will be checkmate for the proponents of the natural theory. Nature does not make right-angle turns. Conclusion. The situation with 3i Atlas feels like a movie plot that keeps getting more twisted. Skeptics are angry. One writes, "Why are you trying to make people seem dumb? It didn't even reach Earth." Others feel that scientists are simply hitting a wall. As another commenter put it, "The problem is that this shit is in space, who knows where, and they don't know how the hell they don't know it. My theories sound a hell of a lot better than what they are aiming for." And that is perhaps the main point. We are standing on the threshold of a discovery that could be either the greatest observational error in history or the greatest event in human history. Atlas is behaving too calmly, too precisely, and too intelligently for a chunk of ice. So what is it? Space debris playing dice with gravity,
or a machine that knows exactly where it's going and why. For now, we can only watch. But one thing is certain. On March 16, 2026, every telescope on Earth will be staring at one single point, and we will be there to tell you what they see. What do you think? Does nature leave such perfect trails, or is this the work of intelligence? Leave your theories in the comments. The craziest ones often turn out to be the closest to the truth.